In the past 800,000 years, there have been large temperature fluctuations, up to 10% in Antarctica. The transition from an interglacial to a glacial period takes tens of thousands, if not hundreds of thousands of years. Unimaginably long time periods from a human perspective, but rather short from the perspective of our 4.5 billion-year-old planet. Currently, we find ourselves in the so-called Holocene. That's the time period spanning the last 10,000 years with a largely stable climate. All major cultural developments took place in this period of relatively stable climate. Our contemporary societies are based on it. However, there were also repeated minor climate fluctuations in the past 10,000 years, which are not related to this cyclical transition from an interglacial to a glacial period. Now, Professor Gerald Haug, director of the Max Planck Institute for Chemistry in Mainz, will describe an example of such a climate fluctuation in the 11th century with the ancient Maya. This example shows that climate fluctuations can become additional stress factors for societies.
The climate system has been dominated by glacial and interglacial periods throughout the last 800,000 years. In the Antarctic, the temperature difference has been about 10 degrees Celsius. This is a huge dynamic. The Holocene is the most recent interglacial period in geological history, spanning the last 10,000 years up to the present day. The overall variability during the Holocene is indeed relatively small. Nevertheless, the small climate fluctuations have had certainly also a big impact on mankind. The impact of the hydrological cycle in the tropics and the subtropics has been particularly large. Let's look at a particular impressive example of how climate change can affect people. The Yucatan Maya civilization flourished from about 200 AD to 800 AD during the Classic period. It then collapsed between 800 AD and 900 AD. My colleagues in archaeology have reconstructed a decline in the population in northern Yucatan from about 10 million people to about 200 to 300,000. In order to understand whether a climatic change could have been a factor, we need to consider those processes of the climate system that are particularly important for this region. This is an animation of the hydrological cycle, which starts in January and continues until December. The animation shows us that most of the precipitation during winter occurs south of the equator, as the intertropical convergence zone moves south during winter and migrates north during summer. As a result, Central America has high rainfall during its summer monsoon. However, this dynamic changes over time. It's decisively influenced by the El Niño events in particular. El Niño is an example of the natural internal variability of the climate system. Ocean currents and winds in the South Pacific Ocean migrate every 2 to 7 years. This affects the hydrologic cycle and thus also the seasonal oscillation of monsoon precipitation throughout the tropics that we've seen in the animation. These seasonal oscillations lead to seasonal layered sediments in very few locations around the world. For example, the Cariaco Basin off the coast of Venezuela. We can reconstruct precipitation during individual seasons for the last 14,000 years on the basis of these sediments. Let's first take a look at a section of this curve. It shows the precipitation amount during a time period spanning from 1350 to 1,000 years ago. You can see that there was a 100-year drought at this time, with a few years of continuous extreme drought events. These short drought events are typical of El Niño years in the region, and they temporarily coincide with the last inscriptions and written evidence of the Maya on their stelae. For example, archaeologists interpret this as the Maya abandoning their cities. This suggests that the climatic changes, the sudden occurrence of extreme drought events, may have catalyzed the collapse of the classic Maya civilization. The seasonal monsoon oscillations are of course not only of significance in the Yucatan area, but rather throughout the tropics. Thus, we have also reconstructed the precipitation on a lake in southern China and have found the same short-term extreme events. For example, diminished East Asian monsoon precipitation coincided with the final years of the Tang Dynasty, one of the most significant dynasties in Chinese history. Hence, due to the timing between the end of the classic Maya civilization and the Tang dynasty, suggests that the same swings in the intertropical convergence zone have had a huge impact on the tropics as a whole. Now, there have been quite a few droughts in the last 4,000 years of Chinese history. Many coincide with a dynasty change, but others do not. This implies, on the one hand, there is a correlation between rapid climate changes and the cultural development in China. And, on the other hand, it also shows us that a society can use environmental policies to mitigate the worst effects of climate fluctuations. The climate system has been dominated by glacial and interglacial periods throughout the last 800,000 years. In the Antarctic, the temperature difference is about 10 degrees Celsius. This is a huge dynamic. The Holocene is the most recent interglacial period in geological history, spanning the last 10,000 years up to the present day. The overall variability during the Holocene is indeed relatively small. Nevertheless, the small climate fluctuations have certainly had a big impact on mankind. The impact of the hydrological cycle in the tropics and the subtropics has been particularly large. The overall variability during the Holocene is indeed relatively small. Nevertheless, the small climate fluctuations have certainly also had a big impact on mankind. The impact of the hydrological cycle on the tropics and the subtropics has been particularly large.